few years ago, and he worked on the Cass News crew, so it was neat to see that again. And Mr. Raskovitz still has his giant cup of coffee. I've never seen him without a big cup of coffee in his hand, so
Never.
some things don't change. My company, I have a little engineering firm. It's called Forthright Engineering. We do product development. We design products that have a lot of mechanical, electromechanical types of aspects to design. And we also design custom machines and fixtures that are used for research and development purposes or early stage manufacturing, things like that. So I just wanted to show you a few examples of the things that we work on, and then I'm going to talk some about the software that we use to design these machines, these products, and then talk a little about why we do that and what that information can be used for, the purposes for it. So this is an example of a little lock that we designed. Would it help to turn out one of the lights, you think?
Sure. Whatever.
Makes it look good.
So we design a wide range of different types of products. This is a lock that's used for gun safes, ATM machines, things like that. So I'm showing some pictures of things that I happen to have in my office. A lot of things we design are too big and heavy or expensive to bring in here, but there's a few things that I have that I can pass around. So if you wanted to open this one, you can just hit 1, 2, 3, 4, 5, 6 and the pound sign. You turn that little ring and it'll retract the bolt. So that's the kind of thing that might be used to lock up an ATM machine, and you can look in there and see how the little mechanism works. This is a machine we designed for a company that's a little startup company that's spun out of NC State, and it's what it does is looks at the coloration and dye machines and analyzes that very precisely using some research that was developed at NC State. But obviously this is a CAD. CAD stands for computer aided design, so this is what we call a CAD model that basically shows how all the parts, the mechanical parts of the machine and how they fit together and so on. So that's what we would wind up with after we do what we do, is a CAD model representation. And the outside shell here's been made transparent, so you can look inside and see all the little parts and pieces in there, which I won't begin to explain. But you can just kind of see that all the shapes, you have little rectangles and cylinders and every kind of shape you can imagine. Everything in here is made up of different shapes that are put together in more complex ways, and we'll talk about how that's done here in just a minute. And here's another example of something we did. This is a little lighter. We don't do a lot of consumer products, but we've done a few. And so this is a little lighter that would be used to start your gas grill. And I brought an example of that, which there's no gas in it, so you won't be able to start it. But for whatever reason, the customer wanted some strange features in it. They wanted a little light you can put in there, and it has a little bottle opener, so you can open up soda or beer bottle or whatever. I don't know why they wanted that, but that's what they wanted. So, and also you can look and you can see that the shapes on this one are more complex, and it's got more curves. If you look at some of the other parts that we looked at in the previous model, they were more simple shapes like rectangles and cylinders and so on. But you can get very complex shapes. In fact, you've probably seen 3D animated movies. The shapes there are very complicated. You know, they look like human forms and so on in modern animation software. Well, it's the algorithms that are used to produce those shapes are some of the ones that are used to produce these. And we can talk about that here in a minute. So what I wanted to do is just talk through how you create. I think you guys are creating. What is it, 7th grade, right? And
Yes.
you're studying. Is this not geometry yet, right? You're just studying shapes and.
Guys, what are we studying? What kinds of 3D shapes?
Okay, so are you learning the mathematical equations for those? Okay. Well, pretty much one of the things I wanted to get across here is every shape has a mathematical equation, and it's important to understand that. Even if you don't remember what all the equations are, you need to understand the principle, and I'll explain why here in a second. But by way of explaining it, I'll describe how we create the parts in one of these assemblies. So in other words, when we look back at say something like this, this is what we call an assembly. It's made up of lots of individual parts. Each part has to be created separately. So take that little, just pick any part here, maybe that handle, let's say. That part has to be created, and then every other part has to be created, and then they all get put together into an assembly. So the way we show the different parts is with different colors. Those aren't the actual colors of the part in the final machine. It's just the color we use to make it so you can see. If everything was the same color, it'd be hard to see one part from the next. So when you want to design anything, a machine, in our case, you have to start out creating all the individual parts. So I wanted to just talk through the process, how to create a very simple part, and there's some specialized software that's used to do that. In this case, it's called a Libra, which is there's a number of different software packages that can range in cost from $1,500 to $5,000 or $10,000, depending on what the software can do. But this is a nice one that you might, if you're interested in this sort of thing, then you can look this one up. It's ALIBRE, and they actually have a free download version that you can use for 30 days, no charge, and they probably even have a student version. A lot of these software companies will sell a student version for $100 or $200. So if this is something you just have a passion for, just point is keep in mind that you could go find this and download it and learn how to use it. They have nice tutorials and everything to show you how to use it, how to get started with it. But at any rate, the way you create a part is you would start out in a two-dimensional space. They call it a sketch. You create a sketch. So in this case, the sketch was created of just a rectangle, it's 1 inch by 4 inches, and you assign dimensions to it. And then you tell it to extrude that sketch. So extrude, you know what extrusion is? Like you take a tube of toothpaste and you squeeze it. The toothpaste just comes out in a circular shape because the outlet of the tube is a circle. When you squeeze it, it comes out as a cylinder. Well, it's the same thing here. You can take a rectangle and you can extrude it, and that makes a block like that, just like toothpaste coming out of a tube. And so then you wind up with something like that. So that's the first step in creating this particular part. And then the next thing that you can do is you can create another sketch. You can select a surface, and on that surface you can create another sketch to add more features. So in this case, it's kind of a little hard to see, but there's a circle here and a circle here. And so you can define the diameters of those circles and their locations from the other features on this part. And then in this case, rather than add material, we'll subtract material. So you can extrude a hole. So then you wind up with a rectangle with 2 holes in it. And then similarly, you can add another hole. So you can create a sketch on this surface. On that sketch, you create a rectangle, and you tell it to now extrude that hole. So now we have a part with 3 different holes, and so on and so forth. The software has other features that you can perform common operations on an individual part. This is called a chamfer, so it just rounds off the corners that you select. So you would select a line, you hit chamfer, and it'll round that over to a radius that you specify. That was a fillet. Fillet is a circular shape on an edge, and this is a chamfer. This is kind of a flat shape on an edge, so you can chamfer corners, and so on. So then you wind up with the part that you were after. This is a very simple part. Parts can get much more complicated. You can add material in any direction you want to, or subtract material, and each time you're creating a sketch, then you're either extruding by adding material, extruding to subtract material. You can do what's called a rotation, where you can rotate the part around an axis and create what looks like a donut almost. There's many different types of operations that you can do, and these are all features programmed into the software. You select a button, you tell it what you want to do with your sketch in order to create a more complex shape. And so then you can add color to it, like I said before, so the different parts have different colors. Now one thing I wanted to point out, and this kind of relates to what you're studying in class, is that these objects that you're creating, the way the software represented isn't just as a point, it just isn't a cloud of points in space. It's actually mathematically represented in the sense that, and the reason that's important is that if you want to make a change, you almost never design something right the first time, right? I mean, every time you design something, you're always going back and changing and changing and changing. Well, every time you made a change, you had to go back and create everything from scratch. It would be very onerous and time-consuming. In fact, that's the way it used to be. And when I started out in engineering, when I was in high school, I had to learn how to use drafting, which was very time-consuming and onerous. Everything you designed, you had to draw on a drawing board. When you made a change, you had to go change that drawing and erase and re-ink, or maybe recreate the whole drawing. It was horrible. I don't think I would have ever become an engineer if that's the way it still was. It was just so tedious and really boring. And then when I got into college, the software started coming out to allow you to do it on a computer, but it was very time-consuming. I mean, you had to program at every point and tell it to connect this point to that point and this point to that point. And then from those sets of points, you would create curves, and then you would create surfaces, and you put them all together. And if you made a mistake, you had to go back and start all over again. So it was like one step up above a drafting board. It was so tedious and time-consuming because every time you made a change, you had to go back and recreate everything all over again, start from scratch. Well, there was a big change in the industry maybe 10, 12 years ago, where the software is now parametric. And what that means is that these aren't just dumb shapes. They actually have formulas that represent every single feature. So So in other words, let's say after we created our part, you wanted to move where one of the holes was. Well, you can come back to that step in the creation of the model, and you can just change dimensions. Say rather than this hole being half an inch from the edge, I now want it to be an inch from the edge. So the software automatically updates. It'll just move the hole to where you told it. You don't have to go back and recreate everything. And similarly, if you wanted to make this hole bigger, you just say, okay, instead of that hole being a 1/4 inch wide, make it an inch wide. And you go back to that sketch, you just change that dimension, boom, it does it. So it's very fast. And so that's it makes it, now I like being an engineer. It's very simple. You spend less time having to create the drawings and the models and more time actually thinking about the design and what you want it to do. And so, but the point I want to get across is, if you think about it, every shape, every model, every three-dimensional shape is made up of surfaces. These are all surfaces, right? So you got a flat surface here, a curved surface here, and so on. Every one of those, all those surfaces intersect at lines. So you can see where this surface intersects. It's an intersection of a line or a curve. A curve can just be thought of a line that's not straight, or a line is sort of a straight curve. You can think of it that way, but it's kind of just, every two surfaces intersect at a line, and then all those lines intersect at points. Well, this part is made up of a database then that keeps track of every one of those surfaces, lines, and points, and it keeps it in a big database. And each one of those are represented with a mathematical formula. So just like there's formulas for a prism, there's formulas for a line, there's formulas for circles, you name it. Every shape you can think of, there's a mathematical formula that represents that. Well, the software keeps track of the formulas for every one of those surfaces, lines, and points in a big database. Every time you make a change, it calculates what the changes to those formulas are, and that's how it changes the shape of the part. So it's really to me, it's a miraculous thing. Somebody was able to figure all that out. And when these things first came out, they were very clumsy. The computer crashed all the time. It didn't work very well. But after 5, 6, 7 years, they got to where they're very reliable. And so it's really kind of amazing when you think about, especially some of these more complex things that I passed around. They have some pretty complex shapes, and the idea that each one of those shapes can be represented with mathematical formulas, to me, is just bewildering. It's amazing that they're able to do that. So just a couple other things I wanted to just touch on. So this is the resolution here isn't showing up very well, but this is a 3D representation of one of the things I passed around. And this is a viewer. It's called eDrawings, and I gave Mrs. Williams a link to where you can download this as a free viewer, and I gave her the databases for a couple of these two things that I passed around. I think it was, or I forget which two they were, but anyway, you can download the software if you're interested, and you can take these databases and you can open them up. And although you can't draw anything, you can at least look at. You can get a sense for how these work. You can look at them and you can manipulate them. For example, you can come in, you can select. This will work here for me. Well, I guess it's not going to work. Let's try this out. Well, my computer didn't like me. And sometimes when I plug into a monitor, some things don't work very well. But what I wanted to say is you can go in and you can select surfaces and you can hide them or make them transparent so you can see inside. Just like I think the lock I passed around had a cover that was made out of a transparent material. It was a prototype. You could look inside and see the parts. You can do a cross section. It's probably not going to let me do much anything here. Oh yeah, so that's a cross section too. So you can make a cross section through it, drag the cross section around. It's not working very well. I'm sorry about that. It's my computer.